Welcome, everyone. I'd like to thank you for taking the time to join us today. I'd like to welcome you to the third webinar in our ice rink series, and we're thrilled to have a number of folks with us today to share their stories on cold water ice resurfacing. And we have Colleen O'Shea from Real Ice here who will facilitate the discussion for us. So before we dive into the stories, my name is Catherine Wilson. I'm the program manager of the Mayor's Megawatt Challenge. We also have Wen with us today who provides the technical analysis for the program. So for any of you who don't know us, the Mayor's Megawatt Challenge has been working with municipalities since 2003 to improve energy use in their own facilities. Two fundamental components of the program include the sharing of knowledge and best practice between the members and our preoccupation with results that are supported by real data. So these components are really core to our webinars, which as you will see in this one are unlike many other webinars out there. So the four pillars of our program are really energy management, knowledge, peer networking, and recognition. So we have provide energy savings and opportunities reports that point to specific areas of opportunity for savings, and these can be shared with auditors who are then tasked with finding those savings. Members also share the reports with their building managers and operators as a means to engage them and to point to the savings that have already been achieved and additional areas of opportunity. We also provide tools such as an electric baseload mini audit that helps pinpoint where energy use is high, and members have used the tool to achieve their targets. And we're currently developing a life cycle costing tool to help make the financial case for energy efficiency and net zero improvements. Recognition is also a big part of our program. So members receive awards for making savings and achieving targets. These have been useful for educating senior management and council, as well as the public on initiatives and improvements. And peer networking is probably the number one, mostly done through webinars, a way for energy managers to connect with each other, as well as connecting their facility managers and operators. So a little bit about how our webinars are different. So member-driven content. So our program is driven by what our members identify as their priorities. Webinar topics are decided by our member municipalities, and we poll members for the topics they really want to hear about. So this webinar is the third in our Net Zero Ice Rink series that supports our Net Zero Ice Rink Roadmap project. And this is an initiative coming directly from what our members identified as a priority for them over the next year, and supported by real data. So our green building performance system tracks building performance and savings so we can measure the impacts of projects. As you'll see, Christina Guido from the town of Caledon is showing actual savings measured at the meter, and that's supported through our data as well. They're very structured, leading to action. So our webinars are not just informational, they're meant to give practical ideas that you can start on right away, things to consider, people you should talk to. We're non-biased and provide information from real people on the ground. And we really highlight successes and address issues and challenges using the experience of real building managers and operators. So our aim is to help you learn from each other, from real life experience, knowledge, successes, and lessons learned. And we really aim to pool knowledge and resources together and really ask the tough questions to get you the answers that you need. Okay, so the pending climate crisis. Municipalities across the country, as most of us are aware, are declaring climate emergencies. And associated with these are greenhouse gas emission reduction targets, some very aggressive, ranging from 50% by 2050 to net zero across all municipal buildings by 2030. So we realize through member interviews and polls that there's an urgent need to collectively figure out practical ways to reach these goals. And ice rinks are a great place to start. 20 to 30% of the energy use in a municipality is in arenas. So they're a great area of opportunity. Large municipalities have many rinks, and even the smallest ones have at least one. And in this case, they're the hub of the community. So a great place to showcase the net zero efforts. And there's 5,000 municipal ice rinks across Canada. So it's really great opportunity to scale up, engage municipalities across the country and across North America to start down the path to net zero. So we're now working with a cohort of municipalities, leading industry experts to develop a roadmap to net zero emissions for existing ice rinks. I'll now turn it over to Wen to give you a couple of details about this before we delve into the operator story.
Thank you, Catherine. The roadmap will follow a systematic process to identify the 4 areas of the integrated solution First, energy efficiency to improve operations and equipment efficiency, and heat recovery to use as much of the waste heat as possible back into the boating. Energy efficiency and heat recovery go hand in hand as the two major components to reduce the demand of the boating to as low as possible. Then we can integrate the renewables to cover the remaining demand, leaving the purchase carbon credits and other offsets as a last resort. We're transforming the industry to get existing boatings to net zero emissions by using ice rinks to map out the foundational approach that can be scaled to all 5,000 ice rinks across Canada, and then to be developed to other boating types. Now, hand it back to Catherine to give you an overview of the upcoming webinars.
Okay, so we have a number of webinars still coming up in 2020, which will cover the 4 steps of the roadmap that Wen mentioned. And recordings and Q&A docs from the previous webinars that we had will soon be available on our website, as will this webinar as well, and will be sent out to all the attendees. So future topics for the webinars include optimizing ice rink operations, which has been shown to be a huge area of priority for the members, as well as geothermal, building automation, and ice rink performance standards. So those were the topics identified for this year. Okay, so we're in the final rounds now of recruiting strategic partners and participants for the Ice Rink Initiative. If you're interested in being a part of the Net Zero Roadmap for ice rinks, please feel free to contact me, and my email is up here on the slide. So without further ado, let's welcome Colleen O'Shea from Realize, who's going to introduce our diverse group of panelists and facilitate today. Hello, Colleen.
Hello, everyone. Thank you very much. Nice to see you all. I guess I'm going to start by sharing my screen. That will be a good place to start. And let's make it bigger. I have to move you around. Sorry about that. All right, you can see my screen now.
Yes.
Resurfacing with cold treated water and debunking the myths. So the following is our agenda. We're going to talk about hot water. We're going to talk about cold water. We'll talk about the economics. We'll have a panel discussion. What is really most important is we have assembled a really diverse group of operators and general managers from different kinds of ice arenas that you can probably identify with. They're going to talk about their experience using real ice and colder water. The panelists are really diverse, and I'll get you guys to wave as I talk, mention your name. So starting off with Håkan Grunlund from H2O Vortex. It's the international distributor of clean tech products, including real ice. Florian Gabriel from Switch Services. He is the general manager of Switch Services, which is the importer in Canada. Christina Guido, who was mentioned before, she's the acting manager of energy and environment from the town of Caledon. Cam Coulter, one of her colleagues who is on the operations side at the Mayfield Recreation Complex. Brendan Barber, who actually stood in this morning last minute for Tyler Seitz. He's the arena operations supervisor at Windsport in Calgary, Alberta. Michael Knight, the arena supervisor of the Sardis Sports Complex out of Chilliwack. Chet Birch, the general manager of the rinks at Exeter, which is a twin pad in Exeter, New Hampshire. Larry Briere from Ice in Paradise. It's a brand new build. Well, it's not so brand new anymore, but in Goleta, California. And Michael Pasaki, who is ice operations for Barclays Center in Brooklyn, as well as the Nassau Veterans Memorial Coliseum in Uniondale, New York. And we also have Tom Smollerk, who is the importer of real ice in the United States. You don't get to see his face, but he's there to help answer any technical questions that we may have some time for at the end. But I'm going to jump into it with Håkan. Håkan, hello.
Hey, good afternoon.
Håkan is the managing director of H2O Vortex, but he's been a hockey player all of his life. And in addition to playing hockey, he's also been an international coach for Luxembourg for hockey. And he's been involved with clean technology for about a dozen years now. So Håkan, tell us, why is hot water used to make the ice?
First of all, I will say if cold water, regular cold water could be used making ice, everybody should use that already today. But we know that the ice quality will be poor. So the industry is using plus minus 160 F to make ice to remove the air bubbles and change the viscosity of the water.
So they're using temperature to actually remove those bubbles, but real ice does something different.
Real ice is using pressure instead of heating up the water. There is a negative pressure of 0.97 bar to collect and remove the air bubbles out of the water. When you remove the air bubbles, the results will be a lower viscosity and a higher density. Another benefit by using real ice is that we crystallize lime particles that will avoid that, for example, the sprayer will be clogged.
So if you're using cold water, you're going to use less energy in heating the water. That's obvious. Where else are the savings?
The savings are in less draw on compressors. And by removing the air bubbles from the water will freeze faster. So you need to raise the brine temperature or the ice temperature.
So with cold water, you see a great variety of the temperature that they're actually using.
So we have in the Scandinavian countries, we have ice rinks using pure cold water, and that could go down to 40 F during the winter. One of the biggest arena in the Scandinavian Hartwell Arena is using pure cold water the whole season. The warmest water we have is NHL is using 100 F, and you can use a temperated water if the arena is or the ice rink is reacting on outside temperature.
We have a picture up on the screen of the real ice. It's not plugged into anything.
No, it's a maintenance-free device. You can install it either horizontal or vertical. It doesn't matter.
So you were talking before about a low pressure in the center of the vortex. We're showing an image right now.
This movie shows how we collect the air bubbles inside the vortex. The small air bubbles will be collected to bigger air bubbles. And that is what you can see in the middle of that vortex.
So it's actually vacuuming, sort of vacuuming it out.
It is, correct.
And the system also comes with a handheld?
Yeah, the handheld is, it's actually an individ of itself. You know, you can use that without in connection with the wall unit. It's spraying a fine mist so you can build up the ice in thin layers and get a perfect base for your ice.
It's been looked at from a bunch of different universities as well as engineering groups. Tell us about that.
University of Massachusetts, Technical University of Eindhoven, Luleå University of Technology, they have been doing different assessment on the technology, as well as several engineers from utilities have reviewed our applications, like Southern California Edison, Fortis, BC, etc., etc. And one of the assessments you can see here is made by Southern California Edison, which shows pre and post installation of real ice according to hardness. And the real ice side was 45% harder than the other side of the ice.
A little later, we're going to talk to Larry Briere about hardness, because he's got a really interesting story to tell. But I guess that hardness is actually the best measure that there can be of what the difference is between real ice treated water and regular water. Is that right?
That's correct. That's correct.
So where is it used?
We have more than 600 installations worldwide. And the picture that you see there is actually the Stadium Series game, NHL, the Ducks against the Kings, 2014 at Dodger Stadium in California. And this is another picture from Lanxess Arena in Germany for the pre-seasonal game between Edmonton Oilers and Cologne Sharks. This arena also have hosted 2 world championships on real ice.
Really good. Well, thanks, Håkan. I'm going to bring in Florian Gabriel next from Switch Services. Catherine was talking about climate emergencies. How is real ice helping with that?
Thanks, Colleen. Real ice can take a really good part in that. And I'll take you back to 2014. That's when we introduced this technology to FortisBC in BC. FortisBC being the largest natural gas provider in British Columbia with subsidiaries across Canada. But basically, FortisBC put on a large-scale pilot equipping 10 arenas and doing the measurement and verification. So what they found out, on average, there's a reduction of about 330 gigajoules of natural gas that can be saved, so roughly 8,700 cubic meters. If you convert that into carbon, that's about 15 to 16 tons of CO2 that can be saved. Going back to Håkon's introduction, there is other savings, that's on the electrical side. So not shaving off the excess heat when freezing the water, but also because of the density of the treated water that's now being kept frozen, operators have to raise their brine and glycol settings by 3 to 5 degrees Fahrenheit. And that accounts for, it's different in every arena, but it accounts for 50,000 to more kilowatt hours of electricity. And again, 50,000 kilowatt of electricity in Ontario, this accounts for about 1 to 2 tons of CO2 due to the source of the electricity. In places like Alberta, the 50,000 kilowatt hours would translate more to 34 tons of CO2. So the spread of impact is wide, but it's, I would say, from 18 to 50 tons of CO2 per sheet of ice per season that can be saved.
And Real Ice takes that into consideration when it's doing its energy savings calculations?
Yes, of course. So basically, once we know a little bit more about the rink's usage, about the plant's age and such, we can render a rink savings estimate, which is pretty accurate. We can pretty much calculate how the savings will look and what the reducing of emissions would look like.
Okay. So what does it cost?
Well, the cost is return of investment. Again, it depends on the electricity and natural gas prices paid, of course, but on average, it's a single pad would look at it under 3 years. A twin pad would be 1 to 2 years. Options to rent or leasing are available. And if you go to the next slide, what's important too, we've seen lots of incentives paid out from utilities across Canada with programs like in BC from FortisBC, which pays $20,000 per system. In Alberta, we have financing up to 75%. And so on. And keep in mind, each of these utilities have to do their own due diligence and verify the technology before they can pay out any funds to any participants. Really
good, thank you. Christina, I'm bringing you on next. Christina Guido, who's the Acting Manager of Energy Environment, Finance and Infrastructure at the town of Caledon. It's all about reducing energy. Tell us about what you did for measurement and verification.
Hi, everyone. Thanks for having me on the line today. And first of all, I just want to give a shout out to Cam, who I know we'll be hearing from next. So we actually pursued this project in large part due to Cam. He heard about Real Ice at the Mayor's Megawatt Challenge Forum. I think it was back in 2018 or 17. So Cam's one of our facility operators and is really bought into being an energy champion for the town. So what we did is we piloted Real Ice at the Mayfield Recreation Complex. So we worked with a third-party engineering firm to verify the savings because this was our first installation of Real Ice. So it's important to note that due to the timing of when the funds were approved to purchase Real Ice, we did the pre-project measurements in March, which would have been towards the end of the hockey season, and the post-project measurements in November, which was at the height of the hockey season. So the third-party engineering firm did have to do some normalizations in order to do an apples-to-apples comparison of the consumption.
Were you surprised about the results?
We were surprised about the results. So I believe the electricity savings actually exceeded what we estimated when we were putting together the quote for Real Ice. So we're definitely surprised on the electricity side, and we've completely eliminated use of gas to heat the resurfacing water at that facility. So it completely eliminated the need for natural gas for the ice rink.
All right. So we also have a ret screen analysis. That's how you're doing your measurement. Whoops, sorry about that.
Yep, so we use Natural Resources Canada Red Screen Expert software to measure the energy performance of all of the town's facilities. So I just included a couple of screenshots of the Mayfield Recreation Complex's energy model. So you can see in the top right-hand corner, I know it's a little bit small there, but that's a screenshot of the electricity QSUM for the Mayfield Recreation Complex, and we use the QSUM to see trends in energy consumption. So when it's starting to trend downwards, we know that the facility is using less electricity than the model predicts, taking into account the use of the arena as well as weather. So if this was bigger, you would see one of the events at the bottom there is when we installed Real Ice, and directly after is when we started to see that downward trend in the electricity consumption at Mayfield.
Really good. So I guess that apart from the ice quality that we're going to hear from Cam Coulter about, the savings are there. You've proven that.
Yep, the savings are there, and it's definitely made the case for us to expand the usage of Real Ice to our other facilities with ice rinks.
And you have intentions of bringing more on?
Yep, so we've actually just submitted a report to council yesterday, thanks to Craig, who's on the line as well, from our division, to request another Real Ice installation at one of our other dual pad facilities.
Yay, that's great. Thank you, Christina. Next, I bring you Cam, and I've got this fantastic picture of Cam, who's actually standing at the Mayfield Recreation Complex next to their Real Ice device. Cam, how are you?
Excellent. As you can see, I haven't had a haircut probably since that picture.
Yeah, and you're growing a beard. So yeah. Tell us about your Real Ice experience. You put it in, you raised your temps. What's going on there?
So we put it in using the wand right off the bat. Found that we raised our temperatures off an infrared camera probably about 4 to 5 degrees Fahrenheit, especially in the dead of winter. As you can see in the background of the picture, you can see the background wall there, it's white and gray. So the physical attributes of our building worked out, because at that gray line, our building's actually below the grade of the ground. So it helped kind of insulate the actual arena, and it can get bitterly cold in there as well. So it definitely helped out with the hardness of the rink.
Did you need to do anything special in terms of maintenance with the Real Ice?
Not necessarily. From an operator standpoint, we actually cut down on, say, ice maintenance. So shaving our corners and edging became, instead of a 3-4 times a day or even getting it daily, it became, a twice a week activity. So we actually brought down our hours, conducted onto the ice.
Okay. Are you running your ice any thinner than what you were before?
We actually are running it a 1/4 inch thinner. So in past, we've been running it about 1 1/4 to 1.5 inches. It's an ORF recommendation. We actually bumped it down, probably down to between 1 inch and 1.25 inches right now. And I don't know if I'd necessarily recommend it for a lot of places, but because of that, the physical attributes of being below grade, it did help a ton in our facility.
Are you on a sand base?
We're on a concrete base.
You're on a concrete base.
Mm-hmm.
Okay.
So actually, when we use the wand too, we actually sub a contractor to come out and paint our ice white, but then our staff put in the lines. Our contractor said it's probably one of the flattest he's sprayed on because of the wand that we just started using this year, rather than the traditional fire hose nozzle.
So the Real Ice adapter, it actually helped you.
And it helped in time-wise too, like less water with the pebbling, that we could go out a lot more often and lay thinner layers of ice that could tack up quicker, and we could get staff back out there, like I said, in a short amount of time.
You also decommissioned some equipment.
So we have an aging hot water tank there that was near the end of its life cycle. So we actually are not using that anymore. And in Christina's previous slides there, that is a gas drawn. So we eliminated that, and then you can see our hot water holding tank there to fill the Olympia. We eliminated that, and the pump to help with the pressure to get into the Olympia.
Really good. Well, thank you, Cam.
Thank you.
Next, I take you to Brendan Barber, who's the Senior Manager of Ice and Billing Operations at Winsport Arena in Calgary. So, oh no, we have Tyler. Come on. Hi, Tyler. Do we hear you?
Yeah, sorry, I just had to unmute. Yeah, no, we've got Brendan as well. Brendan's actually the supervisor here at the Winsport arenas. I'm the senior manager of building and ice operations, but yeah, I can speak, or Brendan can. He's well versed in the Real Ice product as well. So.
Well, welcome, Tyler. I want everybody to know that Tyler is an Olympian, and we're so proud of you just because of that. But we're also really proud of you with what you're doing at Winsport. So Winsport, this ice facility is actually a quad that is on the Canada Olympic Park. Tell us about that. Yeah,
it's an addition to the legacy facilities here from the 1988 Olympics. This was built in started opening in 2010 and completed its opening in 2012. It's 4-pad rinks, as Colleen mentioned. Also has a big office tower, a high-performance training center. It's attached to the bobsleigh and luge ice house. And here at our facility, we have a ski hill, ski jumps, bob luge track. The list goes on. It's a really large campus, and it's a legacy facility from the 88 games. And the facility that you're actually in, it's quite big. It's 750,000 square feet. Would that be right? It's about 400,000 square feet, this new building. Okay. That doesn't include the ice house. But there's about 700,000 square feet of building space on site here. But yeah, behind me is the Winsport Arena. This is a 3,000 seat capacity, Olympic size arena. We hold concerts here, and this is also the home of Hockey Canada. Normally you'd see their nice Hockey Canada emblem at center ice, but due to this circumstances, we have all our ice out for the first time ever. There you go. So you're actually a repeat customer of Real Ice. Yeah. So we, because we have 4 rinks, we have 2 resurfacer rooms, and so we decided we had an issue where we had to take 2 pads out, or actually 3 at one time. So we decided we would install a Real Ice unit on 2 of the rinks just to test it out. So we had a good comparison between A and B and C and D. So yeah, we made ice right from scratch with Real Ice on those 2 arenas, and then went into testing mode. Then you went into testing mode. Did you ever decide to bypass the Real Ice system to see if you could make ice using just regular cold water? I don't think we did we? Brandon, maybe you can speak to that, but as far as I know, we kept it true, and the testing that we did was more based on the 2 rinks that were hot water flooding and the 2 rinks that were Real Ice cold water flooding, and wanted to make sure that the quality stood up. So, Brandon, did we ever do that?
Yes, actually, we did. I think maybe a day or so. What we did was we took the Real Ice system, shut it off, and then kind of pulled a hose from the other side of the machine and filled it up. We only did it for about a day, and we found that with just straight cold water, the results definitely weren't the same in terms of ice quality. The ice quality is Definitely a lot better using the Realize system if you're going with cold water. And yeah.
So the ice quality was there. So you sort of were running a blind test then between rinks 1, 2, 3, and 4, or A, B, C, and D.
Yeah, absolutely. And that was kind of part of the plan. To really get an unbiased opinion, you can't really let anybody know that you're making those changes, right? So we have here a lot of high-end skaters, like from Hockey Canada. We have NHL teams that practice here quite a bit. And then all of our, normal AAA and AA bantam and midget teams. So we installed this without letting anybody know, and we're hoping for some feedback to let us know whether we should continue. And realistically, there was no feedback at all, which is good. And then when we asked for the feedback, we got some surprising results with the 2 rinks with real ice being preferred by even the NHL players. So.
And that's when you actually ordered the second system.
Yeah, that's when we made our mind up that it would pass the test. And yeah, with Hockey Canada not complaining and about any ice quality issues, and as a matter of fact, liking the other rinks better, they all said it had more resilience. We were able to increase our slab temperature or a set point to 4 degrees Fahrenheit. It varies a little bit, but I mean, for the sake of argument, we'll say 3 to 4 degrees Fahrenheit difference. So yeah, we decided to order it and install it in the big rink, and now all 4 are on the Realize system and have no issues.
Really good, really nice. Well, thank you, Tyler. Thank you as well, Brendan, for what you had to tell us today. I'm going to take us on now to meet Mike Knight, who's out in Chilliwack, BC. Chilliwack did have the twin rinks, which is now the Sardis Sports Complex, which is now a triple pad. And one of the interesting things about Mike's facility is that 2 of his pads are on concrete and 1 is on sand. So hi, Michael, tell us about your facility a bit.
Okay, we installed the Real Ice in 2016 on rinks 1 and 2. And then in August of 2019, we completed our 3rd standalone sheet on the site. And with the experience that we had using Real Ice and the rebate that we received from Fortis BC, we even at the contractor tried to talk us out of installing Real Ice, and we said no. We are putting Real Ice in the system, and we're going to use Real Ice for our new sheet, and we've had great ice. And as I've told you before, one of the issues we had with our sand pad is that the ice would crack. Normally in the winter when it get quite cold, we'd develop some big cracks in the ice, and it's a liability for us. And so what we found with using the Real Ice, and we used 70-degree water. That was the compromise that I had to deal with the iceman, and we haven't had the ice crack since we installed the Real Ice, and we've had really good success. So one of the things that you told me before and what's on this picture is 5,000 hours. That has to do with reduced runtime on the twin. Tell us about that. On the twin sheet, yes. That's what we found in the first year of operation with the Real Ice is compressor runtime was down by 5,000 hours with the installation and using the cold water. That seems to be a really big number. It has stayed quite consistent. There's been ups and downs a little bit, but it's been consistent with lower runtimes on the compressors, and it's been good. Well, that's brilliant. So in addition to, you no longer have the spider cracks that you used to and need to do the kind of maintenance that is required to get rid of them, you're also saving a lot of money with regards to runtime. Absolutely, yeah. And for us, it was just a no-brainer to put it in the third sheet. And picture of that's the third sheet that we put in last year and opened last year.
And that hasn't, well, you have nothing to compare it to, but it's also an interesting sheet because it's one of a kind, isn't it?
In the lower mainland, or I think North America it is, because we run an aqua ammonia brine rather than glycol or calcium chloride. And that was a big challenge to get that approved, and the ice really sets up quickly. And we have had no problems, keeping the ice and ice quality has been really good on that side.
What are you running your temps at?
That one we are running it at 22 and a half. And normally on our concrete pad on the twin rink side, we run at about 18 and a half as a set point for the ice Fahrenheit.
There you go. Thank you, Michael. Next up, we have Chet Murch, who is actually in New Hampshire at the rinks at Exeter. Hi, Chet. How are you?
Good. How are you? Thanks for having me.
Thank you, Chet. Chet, I brought you on because not only do you have a twin pad that's on sand base, both of them, but also you were a mid-season installer. Tell us about that.
Yeah, so with the two, sand rinks we decided to install in December and right in mid-season. So what we did was we decided that we were going to go ahead and shave the ice down to basically paint and logos, and then built it back up with the real ice system. We started this process, at 16 degrees surface temp on one rink and 18 on the other. We had a run time of somewhere around 52 hours on the three compressors in a day. And we were able to actually, after real ice, in April, we played with the temperatures a lot, surface temps, and we're running our water in at 57 degrees Fahrenheit is what we're running our water in at. And we played with the temperatures as much as going a little overboard just to see how far we could really push it.
Like
so
how far?
temperatures on one of our rinks now that we're running, we're actually running at 27.5 on one of our other rinks and 26.5 degrees on our other rink. I know that we're pushing the limit, but we've gone that far. We've actually gone higher than that, and started having some softer ice and quality. Once we reduced it down, we found this sweet spot, and again, it's surface temp, on that sand floor. And we find that this works great for us. We've actually reduced our compressor run time to 22 hours a day. So we've cut it, more than in half.
Wow. So you're running at 26 and a half and 27 and a half. You've cut your run time on your compressors by more than half. What's your ice like?
We have great quality ice, actually. We've had some pro teams that have skated out here, some AHL teams and they've actually commented on the ice, on how hard it is and how nice it is to skate. So, we have huge savings and we have good quality ice. So nothing that I would change.
Thank you, Chet.
Yep.
Next, I take you to Larry Briere, who's at Ice in Paradise. I don't know if it's just because it's in California, but Larry, you can tell me a story about the hardness of your real ice treated ice. Tell me about the forest fires that were ravaging the state a couple of years ago.
Oh, thanks for having me, Colleen. I'm not sure which story you're referring to because I can be a storyteller, but I didn't come up with the name, by the way, so don't hold that against me. It kind of grows on you as you hang out in this area. We're in Santa Barbara, as you mentioned. And yeah, we had a series of events in Santa Barbara, forest fires, mudslides, and one thing led to another. And we were shut down for quite a while. And I'm not sure which story you're referring to relative to that, but we've had the Real Ice in since we opened, and I'd used Real Ice in other facilities before, but had problems with operation managers who just love to use hot water. So here we were able to control it from the start, and we couldn't be happier.
Well, really good. This was a brand new build, so you put Real Ice in right from the very beginning?
We did. We're a sheet and a half NHL and a studio sheet. And right now we're running at about 18.5 degrees and get open next week, we think, after being shut down since March 16th.
Really good. No, the story that you had told me before had to do with the facility losing power. Do you remember that?
Oh yeah, well, I remember losing power. And that's another issue with this area. Our power lines go through the mountains and they're above ground. So the area is known for having wind and known for going out of power, and they're slowly putting the power lines underground. But we were out of power for about 4 days, 5 days, and we maintained our ice the whole time. Literally, we don't have backup systems, and it sweat a little bit, but we were worried about losing it, and 5 days later, we were certainly pleased with that.
So you can actually see that ice is so much denser just because it didn't melt on you.
Yeah, one of our benefactors, we're a nonprofit, and Ed Snyder from Philadelphia, former Flyers owner, who has since passed away, is one of the main donors. And when he was getting sick, the Flyers came out here to visit. They played in San Jose, and then they flew down to Santa Barbara that night, and they trucked over here to practice and went to lunch with Ed. This was about 1.5 years ago. And so it's the only pro team we've had on our ice, but it was a great day. I didn't really fly the area, Flyer fan. At any rate, at the end of the practice, Claude Giroux sought me out and just to tell us how great he thought the ice was, and I sent him back to our operations guy to make sure he knew we wanted made ice. So it's always nice to hear from the people, get to skate on the NHL ice to see how we stack up.
Well, exactly. Thank you, Larry.
Thank you, Colleen.
And next I bring you to Mike Pasaki, who's the manager of ice operations at Barclays Arena and Nassau Veterans Coliseum. Hi, Mike. It's a different game that you're playing with NHL teams.
Yeah, I think the biggest challenge is the conversions, because we're not hockey all the time. A lot of the problems that we have maintaining ice integrity is because of the other events. Barclays Center is a little bit busier, but Coliseum has also got other events that come in there. So it's almost like a little surprise every morning when we come in there to start our NHL day.
I bet it is. So you first put it in at Barclays, but you also started using it at Nassau. Tell me about that.
Yeah, it was quick to our situation at Barclays. We needed a different philosophy quickly. We were coming up with other ideas in relationship to the ice with Dan Craig from the NHL, especially because it was the only new building that year. He spent a lot of time working with us, making our ice better, and he was the guy who suggested that we install this. I think he's been working with it with the outdoor games, as Håkan had alluded to earlier. When the Islanders started playing games back at the Coliseum, we were moving one piece back and forth until we acquired another. And so now, although we haven't had an initial ice in with the real ice at the Coliseum, they're both installed at both venues, and any ice making from now on would be done with the real ice.
Really good. So what about the quality? Did it improve?
Certainly. Again, especially we have more experience at the Barclays Center with the real ice. So initially, I assume like a lot of buildings have problems with their ice, and I guess that's why Dan Craig spends so much time with them. But we did notice an improvement in the quality during the first season. And then the second season, I think, is when we actually did an initial ice-in with the real ice device. So that was kind of like a measuring stick for us at that point. The season where they split games for the first time between the Coliseum and the Barclays, there was a long duration where the ice at the Barclays Center was covered for a long time. When we initially revealed it from the ice deck, I think that was kind of like an aha moment for me. And I could almost see like the white paint, like how it landed on the concrete floor. I thought the clarity was that definitive.
So it made a difference to your clarity. It made a difference to your quality. So I guess that's why you're putting it into Nassau Veterans as well.
Exactly.
All right. Thank you, Michael.
You got it.
We're going to go to a little roundtable discussion because we're already at 46 coming on. But I wanted to ask the operators just some general questions and pipe in, put up your hand and I'll call on you. I think that I'll be able to find out who it is. But first of all, how do you tell that the system is working? How can you tell that it's working? Cam.
Sorry, I got to be on mute. I just found during our occupied and unoccupied times, even after floods, we weren't sending on a second compressor because the ice was so hard and coming down a lot quicker. Yeah, it just tacked up a lot quicker. So we, discuss, during your, rep games when they go back to back to back, that during warm-ups, when the kids get on, normally by operator error, there's a ton of water in the middle. So warm-ups, the pucks get stuck, and it wasn't getting stuck. Like 2/3 of the ice, the 3/4 was freezing up fairly quickly, other than the last strip or two when the resurfacer comes off the ice.
Is that a reasonable amount of time?
I would think so. I think based off previous things with the hot water, it spreads a lot more because there's more energy in the water, that it would just take a lot longer to freeze up. So now, kids can go out there and have warm up right away, especially with a limited time of ice times for, having 3 to 4 minute warm-ups before games.
Okay. Tyler, do you have something to add?
Sorry, I couldn't hear the questions on that end. Sorry about that.
Oh, it's how can you tell if the system is working?
Well, really you can't. I mean, skate on it, right? Like it's ice. It doesn't change color with the real ice, so you gotta skate on it and get feedback from the users. And really, it's a difficult thing to measure, right? So that's why we wanted to do the 2 rink tests, and so we could skate back and forth on our normal ice versus the real ice. So that's what convinced us. But outside of that, you can tell. The ice is decent because it's not rutting up. It's the snow that comes off is quite fine and nice. The clarity of the ice is good. It's a hard one to measure. And Håkan, I'm sure if you came up with a measurement tool that you could definitely compare ice, then everybody would have one.
Is this something that you would recommend to municipalities?
Absolutely. Because we did the 2 rink test and compared the ice and had preference for the real ice system, why wouldn't you switch over to it? It's obvious that you're going to save money on heating the water, then also saving on compressor maintenance, and the setup time's quicker. So if you were running a 20-minute gap between ice rentals, you can move that to 15 easy. I've heard of people even going down to 10 minutes. So there's a revenue benefit there. There's just so many benefits to this, and I don't really see any drawbacks, or I haven't been able to see any drawbacks yet. So yeah, I would definitely recommend it if you want to save some money.
Chet Murch, is this technology for everyone?
Oh, I don't know why it wouldn't be for everyone, but I'm sure there are a lot of operators out there who just believe in, warm ice, that you gotta heat, your water up to lay on the ice, and that it just makes better quality. I don't agree with that. And I had a hard time convincing my guys out back that this was the way to go. So much so that we cut the hose so that they can't even reach the Zamboni with any other water except for real ice water. So, But the way that I can tell is when the bill, comes in every month, and I know that, we've done just about as much as we can to cut that cost in electricity. So, Colleen, one of the other things that I'd like to say, is our electricity company, funded us 100%, 50% they paid for the real ice, but the other 50%, they gave me a 0%, loan on this. So I paid $400 a month in my electrical bill until the rest was paid off. So I paid no money up front. And a lot of these electrical companies are willing to do the same thing.
And that's really amazing. What do you think about people who are hesitant about raising the brine settings?
Listen, all that I've heard is, from the people that just don't agree with real ice is show me the scientific, whatever it is. I'm no scientist. All that I can tell you is that you have to be willing to have an open mind and be willing to raise your temperatures and play with your ice a little bit to find that sweet spot of where you still have your savings, but your ice quality is still good. So if you're not willing to do that, maybe this isn't, right for you if you're not willing to go that high. I mean, I did see even some looks on this panel, that we're up at 27.5 and 26.5. I know it's hard to believe, but you have to be willing to really push that limit to make this work.
Exactly. Michael Knight, was there any special training that you needed to do with your staff to get them to?
It wasn't special training, but I agree. It was just trying to get everybody on the same page, and everybody has been just brainwashed that you have to use the hot water, and they just felt that there's no way it was going to work. And, we just had to say, almost the same thing, like cut the hose so you can't use the hot water hose to fill the machine, and use the real ice. And the biggest thing for me was the quality of ice. If the quality of ice went down, we would not use it, was what I said. And the quality of ice did not go down. There's been questions about quality of ice, and that's what we get from our user groups is the ice is really good quality here, compared to other arenas. So, right there, that's what set us for rank 3.
There you go. And you received $20,000 from Fortis BC for your last install?
Yes, and it was very straightforward to do it. It was a form to fill out for Fortis, and then Florian didn't even charge us the extra, just submitted the form. And then we provided some pictures of the install once it was done of the real ice system and how we were using it. And that was it for the rebate, and worked out really well for us.
Really good. So I don't know, Wen, do you have some questions that you'd like to ask our panelists?
Yes, so I've been compiling the questions from the audience groups, and a few people have asked about the experience from different user groups. So curling, speed skating, and other non-hockey user groups. Have you had any feedback from them on the ice quality?
Larry Briere, you know about speed skating.
We don't have curling, Colleen, but we have speed skating. And we have 3 entities, figure, speed skating, and hockey. And feedback's been great. We have probably the best ice in the area. And we try to hit the spot because, one than the other, and you can't adjust it in between sessions. So Chet's got me, I'm going to try to edge my temperatures up, see if I can get up to 25, 26. That's pretty amazing.
Yeah.
Cam? Do you have other user groups?
So I've actually skated on ours. I play in a men's league here. It's a pretty close-knit community, so I get bombarded in the parking lot about other facilities in the town not having good ice and ours being really good. And I didn't even tell them we had the unit. It wasn't until after I told them, and then we get into the data part that Christina talks about, and obviously they like it because tax dollars went to funding it. So yeah, like Tyler was saying too, like just skate on it, test it out. I find that there's no snow buildup or as much. The puck moves a lot faster later in games. So it just, yeah, I find it, you know, good things. I haven't heard any bad things, but mind you, we've only done one season with it.
Thank you. And how does real ice perform on outdoor rinks where temperature and humidities are constantly changing?
Håkan, I'll get you to answer that.
It's no problem. You need to use tempered water for using real ice for outdoor rinks. You cannot use pure cold water because the water will freeze too fast, as well as the rug behind the ice machine will freeze. But it's more resistant to sunshine because the ice is denser. So it works. We have outdoor usage of real ice as well. 400-meter tracks, for example, in Holland. And we have some outdoor installations in Switzerland as well.
We also have one in New Mexico, and they were actually able to keep their ice until past Valentine's Day this year, which is something that they'd never done before. So it actually does work on the outside as well.
Don't forget the Bob Luge track in Königssee, Germany as well.
There you go.
Thank you. And next question is about the difference of using the adapter versus using the Jet Ice Meister for entire ice install. Does anyone have experience of using both and share your experience? I guess not. Okay, we can move on to the next question. Is how does the ice thickness affect the usage of real ice? Do you find any issues with large ruts?
Maybe Florian, you can answer that.
I would actually pass it up to one of the operators. I think one of the operators should speak to that, Colleen.
With large ruts, that has to do with the temperature of the ice more than anything.
Here at Whitport, we've not seen any issues like that at all, really. Hot water or real ice, but I think that's probably more a maintenance issue, the type of water coming in or temperatures. But yeah, we've had no issues with ruts of any kind.
And we have a few questions about the pressure of the water. I think it's around understanding how the system works. Is what are the pressure requirements you need to supply to the real ice unit, and does it drop the pressure once it's out of the unit? Does it affect the pressure when you fill the Zamboni?
Håkan, do you want to answer that?
Yes. We need a minimum pressure of 43 psi static pressure coming into the unit. And we will lose about 7 psi coming out.
And the next one is for operators and facility managers that run multiple facilities. How do you find the facility using real ice compared to not using them?
I guess that would be for Cam. And Michael.
Yeah.
Michael Knight.
I don't know, like we don't use as much gas, or you know, the bills are a little bit lower. Skated on other areas where the hot water's there. You got to go on it. You can tell the difference.
And for us, we have the Coliseum downtown, which is a twin sheet as well. And I hear nothing but complaints about their ice, and I get nothing but praise for our ice. And they don't use real ice in the Coliseum.
Another question is about the water going into the device. Do you use straight city water or well water, or is it treated? What if you have hard water?
So we use city water. It comes into our building at about 60 psi. Temperature ranges from 50 to 55, but by the time it tracks back all the way to the back of the building, you know, it enters the unit around 50 Fahrenheit and about 50 psi as well. So we just use straight city water.
Yeah, we're using straight city water as well. And for us, we have a heat recovery unit on our ice plant. So we did have to keep the boiler and everything in place. And then we just used a mixing valve to reduce the temperature down to 70 degrees. And then straight city water.
Thank you. And one of the last question is, so the question is around treated water. So someone is using a water softener to make ice. Using the real ice system, would the quality of ice be even better if the minerals are removed? And related to this, another question is around, does real ice replace or work in conjunction with a reverse osmosis system?
Very important to understand is that the real ice is not a filter system. So we are not removing the particles out of the water. The only thing what we remove are the air bubbles from the water. And the other question, reverse osmosis. Yeah, it works together with reverse osmosis as well. Reverse osmosis before and real ice after, no problem.
But that depends on your quality of water too. Mike Pasaki, you've got some experience with that.
Yeah, definitely. Again, because we're a new building, common logic is to get a reverse osmosis machine. So we do have one at the Barclays Center, but we quickly learned with the, New York City is renowned for their water, although it's terrific to drink and make pizza and bagels, it's not so great for making ice. So that was actually like one of the first things that we did there is we stopped using the jet ice machine. And then maybe like a month or two after is when we installed the real ice. The water quality in New York City is terrific. Like I said, it's too good.
Thank you so much, everyone. We are on the dot of 2 o'clock, so I'm just pulling up the contact slides for Catherine. If you have any further questions, type in the chat box. We will make sure we'll put together a question and answer document, post the webinar. And if you have any further questions, do email Catherine for more details. Any closing thoughts, everyone?
My closing thought, I would just like to thank you so much to all of our panelists for your really fascinating stories and experiences and for sharing these with us. We really enjoy hearing from you and hearing about real people on the ground. So this was really great. And thank you so much, Colleen, as well, for moderating this so well and for bringing together such a diverse and great group of panelists. This is exactly what we like here. And yeah, here's my contact information. If anyone has any questions about this webinar, past webinars, future webinars, our net zero ice rink study, or the program, please feel free to give me an email, shoot me an email. So thank you so much, everyone, and enjoy the rest of your day.
Thank you, Catherine. I really appreciate it. And everyone on the panel. Goodbye.
Thanks very much.
Thanks so much.
Thank you. Thank you so much. Bye-bye.